All right, folks. Today we are going to talk about geometric series. If you remember, a geometric series, or a series in general, is going to be the sum of a sequence. So if you have a sequence, you've got a list of numbers, and your sequence is, the series is the sum of all of those numbers. So for example, if we had 1 plus 2 plus 4, plus 8, and so on. That is a geometric series because you can see that each term it's being multiplied by 2. And if we wanted to sum up all of these, maybe we wanted to sum to the first 4 terms. So we're going to sum to the first 4 terms. Then we're going to add each of these up. So we've got 1 plus 2 plus 4 plus 8, which ends up being, what is that, 8, 10, 15. So that would be our sum of that geometric series. Now, of course, we're never just given something where we have to add up just four digits like that, where it's going to be a nice, easy problem. So it's usually going to be something a lot larger, a lot more complicated. So we're going to look at how do you add up this, or how do we derive the formula to come up with a geometric series. So we're going to do similar to like we did with the arithmetic series. We're going to look at how this equation is created. So starting with this, we're going to say, let's just look at what all of our terms would be. So we're going to look at it generally. So if we say S of n, so remember this is the sum of however many terms we go to, our nth term is going to be u of 1 plus u of 2 plus u of 3 plus u of 4, u of 4, let's write this properly, u of 4, all the way up to u of n. So we can say we're going to keep on adding that up, and we're going to go up to u of n, which I'm going to put all the way down here. And I'm going to actually talk about the one term before u of n, and that would be u of n minus 1. And I do that because it will make more sense when we start looking at this in a larger, and as we start adding all these things together. So this has all of our terms listed out, but there's no commonality between these. There, u of 1, u of 2, u of 3, but we can put these all in using u of 1 in our common ratio. So if we just take this and we say, well, u of 1, yeah, that's going to be u of 1 times, we could say times r to the 0 power, but I'm just going to leave it at u of 1. And then u of 2 is going to be whatever u of 1 is, times r, our common ratio, to the first power. We can say that to the first power. And then we're going to take this u of 3, that's going to be u of 1 times r to the second power. And we'll see, we'll quickly see how this pattern repeats it, or how we can see a pattern develop here. U of 4 is going to be u of 1 times r to the third power, and we're going to take this all the way up, and we're going to say u of n minus 1, well, let's start at u of n. U of n, if we follow this same pattern of of our u of 1 and our u of 2, so if we follow this same pattern, u of n is going to be u of 1 times r to the n minus 1 power. So hopefully that makes sense, because it's going down 1, our exponent is going down 1 from whatever our term is, whatever our term number is. So that means that the term right before this is going to be u of 1, so we're still doing everything in terms of u of 1, and now it's going to be times r to the n minus 2 power. So it's the one before the last term, so it's going to be, we're going to take off 2 from there. So we're going to look at this this whole bit. Let me get rid of these little dots here, so we can have it nice and clean. So we've got our series written out in terms of u of 1. So that means just using u of 1 all the way across the board. So S of n equals the sum of all of this in the blue there. So here's what we're going to do. So here's how we break this down into a very general formula. It's going to seem kind of odd, but as long as we keep everything balanced on both sides of the equation, we'll be okay. So what we're going to do is we're going to multiply both sides of this equation by r. So we're going to take this whole equation, hopefully it will fit on the board here, this whole equation, and we're going to multiply it. Whoop, I guess I need to get rid of this one down here, because if I put the brackets around the whole equation, that means I'm multiplying both sides of the equation by r. So what that's going to do, that's going to give me r times s of n. So r times s of n. And then if you look at what happens here, our u of 1, it almost looks like our second term now. So this becomes u of 1 times r. And this next one becomes u of 1 times r, r times r, so r squared. And this becomes u of 1 times r cubed. And we can see how this whole thing changes. It basically shifts up and makes our term number, the exponent of our ratio, match the term number that we're using. So here it's term 1. This first one is term 1, term 2, term 3. So now it's matching as we go all the way down. So this is going to be u of 1 times r to the 4th power. And then that's going to keep on going. And so what's happening is we're adding 1r to this. So we're adding 1r. So here, this is going to then bring us into u of 1. And if I've got r to the n minus 2 plus 1, that's going to make this u of r to the n minus 1. N minus 2 plus 1, all in the exponent. So that becomes n minus 1. And then our last term here becomes u of 1 times r to the n minus 1 plus 1, because we're multiplying by one more r. So it's going to be u, or r to the nth power. Okay, so what does that do for us? Well, at that point, we can kind of summarize that if you look at our new red equation, it's identical to our other equation. The only difference is we've got one extra term. So we've got this u of 1 times r of n, which we did not have before. That one we did not have in our blue equation anywhere. So, but everything else, even if we were to go down and look at what would be right in there, that would be our u of 1 r to the n minus 2. So you can see it's the exact same thing, except for we've got u of 1 times r to the nth power. So here we're going to rewrite this. We're going to summarize it a little bit. And I'm going to do something a little different here. Hopefully this will make sense. So we've got r to the s of n equals s of n. So I'm just going to say this whole thing, again, s of n. So the sum of all of this from the blue column minus u of 1. Because you probably noticed that in the red, there's not a u of 1 like there was in the blue. A u of 1 with no r attached to it. So if we take the s of n, which is what we said in the blue, and we subtract u of 1, then we have this thing that we have in the red equation. Hoping this isn't getting too confusing. And then we're going to just add u of 1 times r to the nth power. Okay, so hopefully we're getting somewhere here. So I hope that you understand where this is coming from. This is just, again, rephrasing and substituting by using smaller notations as opposed to having the whole thing drawn out. So now at this point, if I just dropped these parentheses, I'd have r times s of n equals s of n minus u of 1 plus u of 1 times r of n. Of n. Uh-oh, there we go. Let's see, I'm going to need to move this up a little bit, see if I can get a little bit more space here. All right. So now, what are we going to do here? We're going to subtract s of n from both sides. So we're going to subtract our s of n. We're going to subtract s of n. So that leaves us with r s of n minus s of n equals negative u of 1 plus u of 1 r to the nth power. Okay, just doing some basic subtraction, some basic algebra here. All right, so now I'm going to factor out my s of n over here on the left. So I've got s of n times s of n times what? Times r minus 1 equals, and I'm just going to do a little rearranging over here. Here I'm going to do this over on the side notation. So my negative u of 1 plus u of 1 r to the nth, if I just rearrange this, it would be u of 1 r to the nth minus u of 1. So I just did that, and now I'm going to factor out here, I'm going to factor out my u of 1. So when I factor out my u of 1, going back over here to the left, I'm going to have u of 1 times r to the nth power minus 1. Okay, so ultimately what are we looking for? We're looking for the formula for the sum of the geometric series. So I'm going to divide by r minus 1. I'm going to divide by r minus 1. So I'm left with, let me scroll up just a little bit more again. Where am I at? Here I am. Extend that page a little bit. So we are left with s of n equaling u of 1 times r to the nth power minus 1, not in the exponent, that's just minus a whole number 1, over r minus 1. So that's going to give us our formula for the geometric series. So just like with the arithmetic series, now when you're given different scenarios, you have different pieces that you can just plug in, and it's just a matter of plugging in information and doing simple computations. The hard part comes from when you are trying to figure out maybe what term you're going to, or figuring out what term a number is. That's going to be where it gets difficult, but the computation at this point now should be pretty straightforward. Good luck with it.